Hello. The purpose of this video is to illustrate how the special triangles are embedded in the unit circle. So we're going to connect the ideas that we have put together from the special triangles, the 30, 60, 90, and the 45, 45, 90, and then all the analysis that we made of the unit circle for the signs in different quadrants. But this time, what we're very interested in is talking about these special triangles within the unit circle and some very interesting relationships that happen in the different quadrants. So we know that for 0 degrees or 360 degrees, the sine is 0 and the cosine is 1. We already established that the coordinates of the point on the circumference give us the value for the sine, the y coordinate for the sine, and the x coordinate for the cosine. So let's move our cursor, our point along the circle until we find the first special triangle, which is has an angle, a central angle here of 30 degrees. And we can see the value here of the sine of 30 degrees, which is 1/2. The y value, the cosine is √3/2 that we had already established. That's very good. Similarly, I can move here a little more to find the 45, 45 triangle. And we can see that the value for the sine and the cosine are actually the same, which is √2 divided by 2. The way we define it in our analysis earlier was 1 over √2, but we established also that this is the same representation, except we do not have a radical in the denominator. And of course, the tangent would be 1 because we're dividing a number by itself. So 45 degrees. And of course, now we move to the 60-degree angle, which is back to our special triangle number 1. And we look at the values that we have. Same idea, sine √3/2, cosine 1/2. So we have all these easily embedded in the unit circle in quadrant 1. When we keep moving, we realize 90 degrees, we have the sine being value of 1, the cosine 0, therefore the tangent would be 1 divided by 0, which is undefined. Now, here's the interesting part. Let's go to quadrant 2 and find this angle here, which is 120 degrees. 120 degrees. When we look at it, if we look at this orange triangle, we see that this 120 degrees really is our 30, 60, 90 triangle with a 60-degree angle here, the same triangle. So that's the first thing we notice. And we also can see here, we have a kind of a shaded way to show the 60-degree angle here. And there's a connection here that is pretty obvious. I hope you can see it, that because these points are symmetrical, we have that the coordinates, the y coordinate is the same. That means the sine value for 120 degrees is the same sine value as the sine of 60 degrees, which is √3/2. And the cosine has the same absolute value, except in quadrant 2, it is negative. So the cosine of 120 degrees is negative the cosine of 60 degrees. The values are the same. So this is interesting, we can see because of the symmetry. And now when we move to this triangle here, which is, we're going to create another special triangle. This will be the 45, 45, 90 triangle. And we can see that, hopefully when we get it, there we got it, okay, that similarly, this angle is now 135 degrees. We can think 90 plus 45 is 135 degrees. And I can look at this orange triangle and I can see that this is 45 degrees here. And I have the shaded gray triangle on quadrant one that kind of helps me illustrate the connections. And same thing, the cosine has the same value but opposite signs, and the sine is identical. So the sine of 135 degrees is the same as the sine of 45, and the cosine of 135 is negative value of the cosine of 45. Interesting. The tangent, when we realize the same process, we would divide, the tangent would be -1. So it's the same value as a tangent of 45, but with a negative sign because of the relationship we have in quadrant two. Now we move forward and we have now, again, the 30, 60, 90 triangle, but this time the 30-degree angle is the central angle here, and the angle measures a 90 plus 60. This is 150 degrees, that green arc. And this orange triangle, the central angle here is 30 degrees. We call these the related acute angle. So the related acute angle of 150 degrees is 30 degrees because 150 plus 30 equals 180. But related acute means that it's an acute angle, so it's less than 90, and same relationship with the values. Good. So this is what we wanted to illustrate in quadrant two, and let's see what happens in the other quadrants. By passing here on 180 degrees, we reiterate that the cosine is -1, the sine is 0. So to figure the tangent, we would have 0 divided by -1, which would be 0. So similarly to 0 degrees, the tangent is 0, but the cosine has the opposite sign, and the sine, the ratio of the sine is opposite, as the same value and the same sign. Okay, so now let's go to this angle, which is 30 degrees past 180. So 180 plus 30 is 210. And these 210 produces this triangle. I hope you can see now that this is the 30 degree, 30, 60, 30, 60, 90 triangle. That is one of our special triangles. And in this case, the relationship between the values here and the values of our 30-degree angle that we have here in quadrant one are the same values except with negative signs, because this is in quadrant three, but the values are the same. So the idea here, as you can begin to appreciate, is that if we know the values on the first quadrant for sine, cosine, and tangent for special triangles, it's very easy to determine the values for the special triangles in all other quadrants, just changing signs according to where we are in the unit circle, and what quadrant we are. In this quadrant, sine and cosine are negative, therefore the tangent is going to be positive. So the tangent of 210 degrees is going to be the same value as a tangent of 30 degrees. And sine and cosine have opposite signs. This is our 45-45 triangle, which same thing, root 2 over 2 for sine and cosine, but negative. And here now we arrive at the next one, which is again, another 30, 60, 90, but this time the angle here is 60, and I have 180 plus 60, 240 degrees. So the sine of 240 degrees is going to be the same value as the sine of 60, but negative. So the sine of 240 is equal to the negative sine of 60 degrees. I hope you can see this connection. And we're going to move along to 270 degrees, and 270 degrees has a similar situation as 90 degrees, except this time the coordinate for the y is -1, so that is the value for the sine, and the cosine is 0, which means that when I divide -1 by 0, the tangent is undefined. So the tangent for 90 degrees and 270 degrees have opposite signs. Actually, sorry, no, they're both undefined. The sine value has opposite signs, and the cosine is 0 for both. And then we go to quadrant 4. And in quadrant 4, we know that the x value or the cosine is positive, and the y value or the sine is negative. Here we have it. And when we look at it, I have an angle here of 300 degrees, and I can look at it this way. 300 degrees is 30 degrees more than 270, or 120 degrees more than 180. I like to think of the 30 degrees here because it's very easy to see in this orange triangle again that we have a 30, 60, 90 triangle with a 60-degree angle here. And the same relationship holds. This time, the cosine of 300 degrees is the same as the cosine of 60 degrees, which is 1/2. And the sine for 300 degrees would be the negative value of the sine of 60 degrees. So very interesting connections here that we can see inside the unit circle. If we know in quadrant 1 the values for our special triangles, we know all the values for the special triangles that are in quadrants 2, 3, and 4. So I hope this was useful. Thanks for watching.